Hey, Matthew. Here we go. We got lesson 6-4, power to a power. Now we have multiplied exponent with exponents, and we saw when we had the like bases and we're multiplying, we added them. Then the last lesson we divided with exponents. We saw when we have exponents with like bases, we subtract them. And now here's kind of our last um, operation with bases. What if I take an exponent and then raise it to another power? What is going to be our operation with that one? Okay, so when a power is outside of a parentheses, it affects everything in the parenthesis. So this 3 affects the 7 to the second. This 3 affects the h to the third. This 2 affects both the a to the second and the b. So it's affecting everything in the parentheses. So if we do this by expansion, for this one, this would say that I have 3 7 to the seconds. And so by expansion, I could see at this point that I've got 7 times 7, another 7 times 7, another 7 times 7, which means I have 1, 2, 3, 4, 5, 6 sevens. So this would be 7 to the 6th power. So I started with 7 to the 2 raised to the third, and it came out to 7 to the 6th. For the next one, I've got 3 h to the thirds. I've got h to the third times h to the third times h to the third. I'm going to multiply h to the third by itself 3 times. So by expansion, I've got 1, 2, 3 h's there. I've got another 3 h's here. I've got another 3 h's here. So how many h's total do I have? I have 9 h's, h to the 9th. For this one, I've got a squared b multiplied by itself twice. So that would be a squared b times a squared b. So it looks like I've got 1, 2, 3, 4 a's, and I've got 1, 2 b's. So by expansion, I can see that this should give me an answer of a to the 4th, b to the 2nd. Does there appear to be a rule we can use for powers when they're raised to another power? So here I had 7 to the 2nd raised to the 3rd. I got 7 to the 6th. Here, h to the 3rd raised to the 3rd. I got h to the 9th. Here I had a to the 2nd, b to the 1st, raised to the 2nd. It became a to the 4th, b to the 2nd. What do you think the pattern here is for the exponents? Talk amongst yourselves. Come up with it. Pause if you need to at this point. Let's see if you get it right. It appears as if I am multiplying the exponents. 2 times 3, 7 to the 6th. 3 times 3, h to the 9th. 2 times 2, 4. 1 times 2, 2. I am multiplying the exponents in this case. So bases, or exponents of like bases, are multiplied. So we can redo this with this new rule. So here I had 7 to the 2 times 3, which makes 7 to the 6th power, which is the answer I got there. Here I'd get h to the 3 times 3. We get h to the 9th power. Same answer I got there. For this one, we have 2 different bases. So we would do a to the 2nd times 2 and b to the 1st times 2. Which becomes a to the 4th, b to the 2nd, which is exactly what I got there. So if we have like bases, we are going to go ahead and multiply the exponents if it's a power to a power situation. All right, so what do we do if we have coefficients and exponents at the same time? So exponents and coefficients, again, they always behave differently with powers raised to a power. While exponents are multiplied, the coefficients should be taken to a power. All right. So for this one, my coefficient is 2. So I'm going to take 2 to the second power, and then this is c to the first raised to the second power. So 2 to the second power is 4, and c to the 1 times 2 is 2. So 4c to the second. For this one, if I were to expand it, fractions throw some people off, but if I were to expand this, this would be t to the second over 4, d to the second over 4, d to the second over 4. So I can see here that, yes, I am going to do d to the 2 times 3, and then the denominator is also going to be taken to the third power. So this is going to be d to the 2 times 3 over 4 to the third power. 4 times 4 is 16. 16 times 4 is 64. Might need calculators for that, so we would get 64 in the denominator. Numerator would be d to the 2 times 3, d to the 6th. Next one, -5 to the second power, and then x to the 11 times 2. -5 times -5 is positive 25. And then x to the 11 times 2 is x to the 22nd. Next one, we've got -3 to the third power. I don't know why I wrote it down there. Whatever. Then we got m to the 1 times 3 and n to the 5 times 3. So -3 times -3 is positive 9. Positive times another -3 is -27. M to the 1 times 3, m to the third. N to the 5 times 3, n to the 15th. All right, we got 9 delicious practice problems here. Why don't you go ahead and try them out if you're doing this from home for the first time. So go ahead and pause it, and then you can see how you did. All right, hopefully you're unpaused now. Let's do it. 15 to the 5 times 3. 15 to the 15th power is our final answer. Y to the 10 times 2. We get y to the 20th. This one, we've got 2 bases, so we would do r to the 3 times 7 and t to the 1 times 7. Final answer, r to the 21st, t to the 7th. Next one, the numerator and the denominator are taken to the power. So we've got 5 raised to the third power and x to the 1 times 3, because it's x to the first down there. 5 times 5 is 25. 25 times 5 is 125. X to the 1 times 3, x to the third. Next, 2 to the 4th over m to the 8 times 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th is 16. M to the 8 times 4 is m to the 32nd power. Next, we do 2 to the 5th, and then d to the 1 times 5. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 2 to the 5th is 32. D to the 1 times 5, d to the 5th. Next, 8 to the 2nd, and then k to the 6 times 2. 8 times 8 is 64. 6 times 2 is 12. So we get 64 k to the 12. Next, we take -3 to the third power. X to the 12 times 3. Y to the 1 times 3. -3 times -3 is 9. Times -3 is -27. X to the 12 times 3 is x to the 36. y to the 1 times 3 is y to the third. Last one. Negative 5 squared, a to the 7 times 2, b to the 9 times 2. Negative 5 times negative 5 is positive 25. A to the 7 times 2 is a to the 14th. B to the 9 times 2 is b to the 18th. Done. We did it. Nice job. Oh, that one was only 10 minutes. Killing it today. All right. Math hard. I'll see you guys later. Bye-bye.